I'm seeing the rec now.
Yes, if you can start.
Okay, so I was thinking present like this, but like using this split screen, but I don't know if it's okay for you, or if you prefer something more. I don't know. But we have the uh, our paper link where I discuss something and pointed out my what I think that's the most important thing that they are discussing in the data2vec paper. So feel free to reach it out or to in the paper as well, where you are here, or if you want to follow the doc, just follow the doc. The doc is open to all people from CloudWalk. So I think that could be uh, nice. So okay, so basically, I want to talk about the motivation. I think that there are a lot of people at our team that are working with representation learning. I think that are not. It could be not so well defined or very well defined in a way that I'm doing representation learning, but in general, Fabio is doing that a lot. Me and Daniel that are working with embeddings are doing this a lot. I think that Alan that will could start to use and to decompose some graphs in order to generate new embeddings, and it will be doing this a lot. So basically, I think that this paper could be used not in a way that we will implement the paper itself, but in a way that this discussion that I will bring to you today will at least fire some ideas or generate some insight. So basically, the paper treats about self-supervised learning, uh, and basically what they are trying to do is to learn meaningful data representations from different domains, or data from different domains, different natures of signals. So basically, they propose a new framework that could be applied to analyze image, to analyze speech, and to analyze test data. So this is the core idea of the paper, as you can see here. And basically, they are proposing using the self-supervised learning because we have a problem with those kind uh, of signals. Because we need to, in general, as we are trying to solve a regression or a classification task, we need the label, or at least what we think that label are for the data itself. So this idea is to create a framework that will use the data itself to generate and to learn what they need to learn to solve the problem by itself, with or at least with less human effort in order to create and to label this data. I think that this is pretty related with my problem with the chats, because we have a lot of data. There's a lot of chat that we need to label in order to guarantee that the labels are correct and the labels are good for solve the problem that we are trying to solve. Either question and answer for the linear process, or concept drift, or then topic identification, or entity identification. What else? So basically, they are proposing a new model that uses a transformer architecture, and they combines basically the learning of the representations, okay, with a mask process. But it's not so general as the name proposed, because as each signal domain has its own properties, in order to create those kinds of structures to process the data in order to be able to feed the algorithm, requires more specific ways of treating. So, for example, if we are treating of image, the masquerade process is just to take some part of the image that are in the interest, and we input some random noise and try to predict this random part of the image itself. So for test data, we could just hide some part of the phrase and try to predict this hide part of this phrase. So for speech analysis is a little bit more complicated because the way of the utterance are made by our trait vocal uh, requires some kind of careful treatment because in general, the way that the utterance for vowels and consonants are did by our language generates some kind of correlation between this step or the frame data itself. So it's a little bit tricky to mask basically the speech signals. So this is the whole idea. And by definition, as they are not treating about the definition of the self-supervised outputs, a definition here, and basically is the self-supervised learning is used in many data contexts, so, audio, test data, and image, in order to what we try to do is to generate a supervisory signal to solve some tasks using the inner data, the data itself. So the idea is to use part of the data that we already have to learn the representations as a pre-trained process. So after we learn these representations, we will use these representations that the algorithm created or learned by some process to feed another model that will in fact solve the problem. So there are two steps. Learn the representations by itself, use the representations to solve the problem. In order to do that, the people are proposing some kind of contrastive SSL. Each link that are with this hyperlink has a link to another article that I think that could be interesting in order to understand better the concept behind of the definition that the link are referenced. So basically, we have this process, these two process, the learning process of the representation and the solve of the task. In order to do that, we need to provide for the model an objective function that will be minimized for both steps. So we have two ways, basically the contrastive self-supervised learning or the non-contrastive self-supervised learning. I didn't digging out or digging in deeper into these two definitions, but I grasped the idea, I think. Basically, contrastive SSL tries to minimize the distance between the positive labels that we are feeding at the algorithm. For example, if we are trying to create an architecture to do image classification, we will try to mask the input image with the objective function of that image that we want to predict. And this will be labeled as a positive image that we want to do. In the other example of the non-objective class will be the negative classes. And the algorithm will try to maximize the distance between the positive labels. How we can maximize the distance between positive labels if we are working with images and the text and video and anything that could be measured by the or used as data with the representations learned in the step before. Because of that, it is very important. So basically, it's that the way. It's pretty straightforward. We are maximizing the distance between the positive labels, so we will be clusterized, or the positive labels will generate some clusters in this new vector space, and the negative labels will generate another cluster where it will be different of the positive clusters. In general, they are using variants of the Kubac label divisions because we are able to treat those kinds of new vector space in a very handful way. The non-contrastive learning basically uses only the positive labels. And I don't know the reasons of the whys, all the whys, but they provide a way of thinking that makes sense for me. That is by only looking at the positive labels, we are basically sampling the positive space. We are not searching in the negative space. And for some cases, only looking at that space generates a convex region for the error surface, where this convex surface enable us to find a minimum, a local minimum that could be used as the start point for solve the problem. So the representation learn process will stop when we reach out this local minimum at this part of the training process. So after that, we started to learn properly to solve the problem. So uh, those two basically ways of doing supervised, self-supervised learning. And I think that everyone, if everyone has some doubt, please reach. I I don't know. Is everyone hear me well? They both. It's okay.
Yeah, yeah, we can hear you well. Yeah.
Okay, nice. So for this problem, they are using the representations, and we have the introduction part of the paper where they are talking about the models that are doing the same or a similar way of thinking, and they are treating. But basically, what we could extract from here is that uh, the research, this paragraph here, and the research in self-supervised algorithms has focused on individual modalities which result in specific designs and learning biases. So basically, for each domain of data, we have a process to follow. And each domain will require, as I said before, um, the only his intrinsic ways of treating this data. So because of that, the self-supervised learning has become a hot research area, and they mention examples of the ways of processing those self-supervised learning, each task for each domain. So the work, the data2vec, tries to unify the learning algorithm, but still learn the representations individually for each modality. So we are able to learn some kind of representations that will be useful not only for solving the data or the problem that we want, but for example, to extend and to combine or analyze the representations or this new vector space that represents all that stuff. So the method base combines a masked prediction with the learning of data and target representations, basic embedding. We mask basically what they are trying to do. What they are doing is we have the input, we mask part of this input, and we will learn an embedding for this masked step or for this masked input. Uh, they are calling this step, this first model, as a student that will have this new the all data without masked process. And we have the teacher model that will learn the embedding for the non-masked input. And the idea is to make the student model that has the masked input to learn and the representation learned by the professor or by the teacher model. So this is the way that the model, the data2vec works. And we could see here, I want to show uh, a little bit. So the example that they have mentioned is that we have this image of a dog. They masked the face region of the dog. For the speech, they are just masking some part of the speech. For a language, we are uh, just out what is part of the sentence itself. And after that, we learn the representations for both, and we will try to learn from the student mode or to minimize these objective functions between the representation learned by the student and by the teacher mode. So this is the idea. Uh, so they are trying to minimize, and the way that they encode it will be different for each domain. So because of that, I don't think that it's so general as they said, but I think that the framework or the general idea of the framework is generalized. So basically, our target representation are continuous. So this is pretty nice because for all processes that are involved in learning something from data, it uses some kind of differentiation process and gradient descent based algorithms in order to become or to do the optimization process. So the ability of construct these representations in a continuum model and a contextualized version. I don't think if everyone will remember, but I started to design with Ale uh, something of something related with a context model for our motions, where we will try to learn an embedding representation that will try to make it will not will try to capture more of the intrinsic of the relationship between the merchant itself. So not only the data point will the single data point will generate information for the model or for the representation that will be learned, but also we will also provide for the model information regarding this neighborhood the neighborhood of each data point. So it will be a contextualized version of the data itself and not only the single data point. So this is pretty awesome because uh, they just mentioned that, okay, if you could create a general way of input for the model, this context, you will be a model that will be more generalizable, I think. Sorry. A more general model and these capabilities of this model to be extended for other tasks also could be improved. So at this part of the this is something that I put here and the strength of the article in the doc. So we will learn the representations from the input data as the teacher mode and student mode, not only the teacher mode. Uh, and we will encode a masked version. And this masked process of encoding will generate a continuous domain, the latent space learning, and will also take into account the context of each data point. So it will be great. Basically, here they are trying to compare this work, the data2vec, with the other approach that are using or trying to use self-supervised learning for the three principal domains that they are mentioned: computer vision, NLP, and speech process. And basically, they are trying to, there is, for each process, basically, there is not a way of pre-processing the model. So they are focusing inside of each domain particularity. So they each model that are trying to apply the self-supervised learning takes account the processes of the each domain basically. And for example, for the computer vision, they are trying to, as they are using a transform combined with a distillation process, the transform by design takes account with the attention mechanism, the context about something about the data set or about the data point itself. And for computer vision tasks, this is pretty interesting because in the most applications where semantic analysis or segmentation process or semantic segmentation are being applied, the relationships between the neighborhood of the pixels that are interested, in general, they are correlated and need to be taken account in order to create a robust model to identify those patterns in some kind of transformations or to create some model that will be invariant to some transformations. For the NLP, it's basically the same, but in general, the embedding that are learning takes account each each token inside of the process. And this model here, as they are using this distillation of with the transformer architecture, basically they are not learning one representation for each token, but each representation will be related with several tokens. And they are trying, for what I read, this increases capability of generalization of the models of these representations learned by the algorithm itself. Okay, and for the speech, basically we have this wave-to-vec model, and basically one thing that's pretty impressive in the data2vec is that we don't need to quantize the signal itself. So the quantization is important because when we have uh, a speech signal that has noise, basically the noise spreads out for the whole spectrum. And when we quantize, we diminish the impact of the noise because we are just limiting the capabilities of the signal itself. So probability of with less probability of being some kind of with less probability of this corruption uh, be effective with less uh, levels of energy for the signal. So this is a great advantage of data2vec in comparison with wave2vec. Okay, so multimodal pre-training is just the process where they are trying to work with different signals and they are just detailing the whys and the modes basic. So multimodal modality here in the concept of this paper is just the nature or the domain of the signals or the data that we will be using. So the method, they create an encode masked version of the train, and then they construct the train target after the target representation be learned, all the information in the training sample and the learning task is for the student to predict these representations, giving a partial view of the input. So this is the whole problem. And after that, we are able to solve the problems. So the architecture model is a standard transformer with a modality-specific encoding of the input data. So for computer vision, they're using this kind of pre-processing. And also for the specific data, they need to provide a new pre-processing step. So the masking is just it will be deferred only for the speech because we need to take careful, as I said before, because the regions where we will be masked need to could be correlated and important for the process itself. So we just need to get more careful. And the training targets. So the model is trained to predict the model representation of the original unmasked training sample based on an encoding of the masked sample. We predict the model representations only for time steps which are masked. So this representation will be contextualized because they are using the transformers, and we have this kind of advantage for using this architecture. Okay, so the teacher parameterization is a way that they are um, using for learn the representations for the model in the teacher mode. So basically, they are doing an exponentially moving average in order to, as the times go on with the training, the parameters of the teacher model will stop to be learned. And this is good for diminish the probability of getting overfitting representation. And the targets, okay, this is pretty interesting because in general, the problem that are being applied self-supervised uses some, uh, for example, for the classification process, they are only at the top of the last layer of the transformer architecture. They are just creating some of new representations. And for the data2vec, instead of one, they have a bunch of transformer architectures. And this is the way that I think that is the most important thing about this work, because with this uh, this amount of transformers, we are able to capture more of the computational complexity of the data. So the structure of the data, it's more, I don't know, better. And I think that this is the why this model is just was able to become a new state-of-the-art baseline for some of the contests that they are providing. So basically, they have those transform layers, and they are averaging the output of each transformer layer. By doing that, they are just, I don't know how to say that, but they are filtering only the remain, the important part, because we could see a mean as a low pass filter, and this is why the way that I understand this better. So if we have some kind of difference or greater difference between the output of each transformer layer, by filtering this out, we will get a more smooth or a more smooth output. And this is the way that they are trying to do this. So basically, started to start experimentation without the adding of each transformer layers, but basically after that, they noted that the adding of some layers makes the exploration and the generalization capabilities of the model to increase and become better. So I think that this is what I want to talk for this part of the model. And one pretty interesting thing is the combination of the objective function that they use it for the process of learning. So they combine basically two um, objective functions, L2 norm, that's the normal one that everyone uses, and the L1 norm. So it depends of the value of beta, so it's not so easy, I think, to I don't like the of this kind of model that we need to trick and to study some parameter in order to find the best parameter, because each parameter that we are adding increases the complexity of the model for greater levels. But we by using those two levels, we are basically get in the same way a smooth version of the error space, and also a model that will be robust to outliers due to this L1 objective function here. So it's just, I think that this is interesting for to note and to mention, because in only they created a way in order, or they created a way to generate a smooth version of the error surface. At the same time, it's just robust to outliers. So I think that this is pretty awesome. So after that, they will explain the experimental setup, and as you may say, is that, guys, it's a monstrosity of model. So they for the NLP test, they are just trialing that they using, I think here, those 16 GPUs. I don't know. It's a huge model, in order to. No, I don't have any idea about how to train this kind of model, but yeah, the models are pretty huge, and they are trying to they explain at this part the parameters that they use it to create the models and the optimizers or and other stuff that are related with the training process. After that, we will have the result of each baseline for each domain, for computer vision, for NLP, for speech processing. Uh, and basically, this data2vec is able to outperform uh, all the recent advance. And all the recent advance is this work is 2022, and they are being compared. The guys are comparing with models that are being 2020 and 2021. So it was a pretty recent experiment with the batch that we got um, for these models that we have that are available. So it's pretty state of the art process. So basically, this is it for the model itself. It's a pretty huge model, and it's a pretty, I don't know, a pretty awesome result. After that, I think that the most important part is the discussion about the whys that this model are working so well and the conclusions of the article. So basically, for this discussion, we have the primary goal of this study is to design a single learning mechanism. And yeah, I don't think that it's single because if we need to adapt for each domain of data, it will not be a general way. So I think that's not so single, it's not so general. But in terms of framework and the way of thinking how to process in the only way uh, the learning of representations that takes in account not only this information about the data point itself, but the neighborhood or the context of each data, and be able to solve regression and classification tests. I think that, okay, a general way. It's best, it's general for this kind of situations. So for that, I think that okay. And basically they are feature structures as this or this new latent space. We could think the latent space as a feature space. And for each process, they are just trying, okay, each form of data will require some kind of preprocessing. After that, also they mentioned that the data also impacts how we should match the input. So removing individual words provides a sufficiently challenge task, but for speech, it's necessary to match spans since the adjacent audio samples are highly correlated with each other. Okay, this makes sense. And about the other work, this work here, and they mentioned that okay, this work is focused on a supervised learning for classification tests, and we believe that our work is complementary in the sense that they will try to learn something or to modify the architecture for the perceiver model. I put the link for the perceiver model here. I think that it's pretty interesting. The way that they are trying to model the information, how the network will be constructed. So basically, this is it for the structured and contextualized targets. So one of the main differences of that track to most other masked predictions is the way that we are trying to create this masked process. So we need to take account uh, the domain and the relationships between adjacent samples. So in general, it's better not to provide only one single data type or single data sample or single data point, but we need to be careful if the data that we had are very correlated with uh, the other data points that we had in our space. So in comparison to data2vec, has no limitation in the number of target units instead of representing distance of particular discrete target unit. I don't know if everyone remember, but at the not at the beginning of the presentation, but I mentioned that in general we had an embedding for the NLP process that will be related for each token. So we could interpret this target unit as the token. So we will be able to get better contextualized version of the token, not an embedding for the token itself. Representation collapse is just a way of getting your model, the model explodes or the model is not learning, so they are calling representation collapse. And this occurs when the model produces very similar representations for all masked segments, and they propose uh, this process here. The EMA helps to solve, and also the L1 normalization process is also able to solve the process. But basically, for the causes that they mentioned that are related with the representation collapse are the high learning rate. We need to take care of the moving average that will be applied to the model, and the correlation between the data points that we have. And penalization of variance. This penalization of variance is just being account. Here, we could, if everyone knows about PCA, we could train an autoencoder minimizing this function, and the result is the same as the PCA if the layers of the autoencoder is linear. So we are trying to maximize the variance between each class. So I think that this is the most important part of this result, these results parts here. And for the conclusion, they mention, okay, the idea is to regress contextualized latent representations based on partial view of the input sample. If this objective is accomplished, we are able to get better representations and the model will be generalizable in a better way. After that, this is the only method, a single method to learn in multiple modalities will make it easier to learn. But again, I don't agree with this. It's not a single method. I think it's more a way of thinking and not a method itself to learn in multiple modalities because we need to take care with the data domain. And they will try to work at the masking process and in the other architectures instead only the transform one. So I think that this is it, guys. This is what I prepared for you. Just let me know if you have any doubt or if we can discuss something.
Thank you, Israel. Any comments here, guys?
Well, there is something that I think it's interesting to notice is that, as I understand it, the self-supervised learning name is just another way of saying unsupervised learning, which Yann LeCun prefers. Because in his view, in unsupervised learning, you are not really learning without looking somewhere else. You are looking internally into structure in your own data. So that's why he prefers self-supervised. You have a target, right?
You have a target.
Yeah. So
they need to make a target. So it's not.
Yeah.
So
yeah, what I see is that Facebook team tends to use self-supervised learning, but it's not a term that
the correct
is
one.
widespread. Yeah.
Yeah.
There are many people still using unsupervised learning, but they are the same thing as I understand it.
Yeah.
And maybe another point, just to clarify, it was not clear for me when I started reading the paper, is how did they map the image domain to a sequence input to the transformer model, right? And then I
They did,
understood that they create patches in
yeah.
the images, and then put them in sequence to transform each image in a sequence of paths, right?
Mm-hmm. Yeah, this path image, this path creation is used the vision transformer process. I don't think you because this part they just okay, we use
Oh
the
yeah,
same process as the vision transformer and you have to create the path. I think Anna present to us the vision transform process and the article they are mentioning how the paths are constructed. But basically they just manually label what is the region. So for example, if you want my face as a interest region of the detection that we want to do. So we will point it out, and this will be a patch. All this region of my face will be one patch into this, I don't know, sequence of Israel image frames that has only my face, for example. And for each patch, this is the patch that they are mentioning. Did you get the idea?
yeah.
So this is it.
I
I'm not, for me, it's better to just to call. Okay, we create a graph where we try to retain the information of the pixel in its neighborhood. So um, I think that this is better to.
yeah, it's clearer now for me
Okay,
how they how they did that.
yeah, I think that the people when they put this fancy word at this buzzword, they are trying much via I don't know. They don't want that us to understand well what they are trying to do, but yeah, it's just a mapping of what is the region of interest. I think that this is pretty annoying for doing it because we at least it will be necessary to manually identify points before be able to apply this kind of usage of transformer method. And it's pretty hard. It's not so easy as they pointed out at the article. It's a difficult task also. But after we get the data, it's just it's just feed to the network, and the network will do this the work that it was proposed to do.
Yeah, thanks.
Nice, thank you.
Any other comments here, team? Ideas, suggestions?
I have a topic like how do you see this working? Like how could like not necessarily I don't know if this discussion should go like but I was thinking through the whole paper like how could we try to use this in our context? Yeah, I don't know if we should talk about our context.
No, yeah, we can stop the recording. Don't worry. I will stop recording.
No, but like I don't know if there are things that there are other
Oh, it's
comments
okay, dude. Don't worry.
maybe.
This is the focus is our discussion, not the video.